Good day. We are Group 4 presenting Combinations, and I am Ulrika Sepp, your first reporter for this topic. Combination is a mathematical technique that determines the possible arrangements in a collection of items where the order of the selection does not matter. In combination, you can select the items in any order. Combination of n distinct objects taken r at a time where r is less than or equal to n. We can represent this statement using this symbol, which its formula is n factorial over the quantity of n minus r factorial times r factorial, where c is the total number of combinations, n is the total number of distinct objects in the set, and r is the total number of choosing objects in the set. So we will use this formula to solve the combination. Let's have an example. So let's evaluate the following. We have number 1 here, the combination of 7 taken 4 at a time. Let me repeat, the combination of 7 taken 4 at a time. So let's identify first the value of n and r. Let's remember that the value of n should be higher than the value of r. So the value of n here in the example number 1 is 7 and the value of r is 4. Using the shown formula earlier, n factorial over the quantity of n minus r factorial times r factorial, we can solve the combination. We will just gonna substitute it. So 7 factorial over the quantity of 7 minus 4 factorial times 4 factorial is equals to 7 factorial over 3 factorial times 4 factorial. Next, we will expand the 7 factorial, so 7 times 6 times 5 times 4 factorial. It only ends in 4, so that we can cancel the 4 here at the bottom. So 7 times 6 times 5 over 3 factorial is equals to 210 divided by 6, which the answer is 35. Let's continue solving example number 2. The combination of 52 taken 3 at a time. So let's identify first the value of n and r. We can see that 52 is more bigger than 3, so our n is 52 and our r is 3. So 52 factorial over the quantity of 52 minus 3 factorial times 3 factorial is equals to 52 factorial over 49 factorial times 3 factorial. Next, we will expand the 52 factorial. So 52 times 51 times 50 times 49 factorial. It only ends in 49, so that we can also cancel the 49 at the bottom. So we will also expand the 3 factorial, which is 3 times 2 times 1. By cancellation method, we can cancel 50 and 2, so 50 divided by 2 is 25. And also 51 and 3, so 51 divided by 3 is 17. To get the final answer, just multiply 52, 17, and 25. So the answer is 22,100.
Good day everyone, I am Arbastolfin Cristil and I'll be showing you some of the examples. A group of people from Canada wants to visit Cebu, Philippines. A tourist guide suggested some of the nice places to visit, namely Fort San Pedro, Oslo, Magellan's Cross, Kawasan Falls, and Temple of Lea. In how many ways can they select 2 places out of the mentioned places? If you try to list all the possible combinations, it is time consuming. That's why we have the formula that we can use to find the number of combinations of objects. We can say our n is equal to 5 since we have 5 total mentions of places. And r is equal to 2 since we are selecting 2 places at a time. Now we can substitute the given values to the given formula. So we have combination 5, 2 equal to 5 factorial over the quantity 5 minus 2 quantity factorial times 2 factorial. We can now evaluate our equation by completing first the operation inside the parentheses. 5 minus 2 equals to 3, so now we have 5 factorial over 3 factorial times 2 factorial. Expand both the numerator and the denominator, so now we have 5 times 4 times 3 times 2 times 1 for 5 factorial, 3 times 2 times 1 for 3 factorial, and 2 times 1 for 2 factorial. We can now cancel 3, 2, and 1 both in the denominator and the numerator. 5 times 4 is equal to 20 and 2 times 1 is equal to 2. Now for the last step, 20 divided by 2, that will be equal to 10. Thus, we have 10 ways. So now for the next example. In how many ways can an examination committee of 4 be chosen from 9 teachers? Since we have a total of 9 teachers, then n here is 9. And we are going to choose for examination committee, thus r is equal to 4. Given the formula, now we can substitute our given values. So we have combination of 9, 4 is equal to 9 factorial over quantity 9 minus 4 quantity factorial times 4 factorial. Simplifying the equation, 9 minus 4 is equal to 5. We can write our numerator 9 factorial in the form of 9 times 8 times 7 times 6 times 5 factorial, so that we can cancel 5 factorial in numerator and in denominator. We know that 4 factorial is equal to 4 times 3 times 2 times 1. By getting the product of the factors of numerator and denominator, we have 9 times 8 times 7 times 6 is equal to 3024. And 4 times 3 times 2 times 1 is equal to 24. So 3024 divided by 24 is equal to 126. Thus, we have 126 ways an examination committee of 4 can be chosen from 9 teachers.
Thank you very much po. And the commentator for this section is Kitbat Yunibaga. And for this example, let us try something to those who wishes to win a lottery. Now, a player chooses 6 numbers from 1 to 42 in no order. How many possible bets are there? Again, we will use the formula that we used in the previous examples and substitute the variables. So we get 42 combination of 6 is equals to 42 factorial notation divided by open parentheses 42 minus 6 close parentheses factorial notation of 6 factorial notation. Well, obviously you first have to solve the parentheses and expand the thing for you to see further. So we get 42 times 41 times 40 times 39 times 38 times 37 times 36 factorial notation divided by 636 factorial notation and 6 factorial notation. We then cancel out the identical numbers, which is 36 factorial notation. And such, we have 3,766,965,920 divided by 720. Or, if we simplify it, 5,245,786.
Hello everyone, my name is Matt Lansang from Group 4 and I am here to show more examples. First example, how many committees of 6 persons can be chosen from a group of 15 persons? To solve this, we need to substitute the 6 and 15. The 15 goes to n and the 6 goes to r. And we have 15 factorials over 6 factorials times 15 minus 6 factorials. Subtract the 15 minus 6 and we can get 9 factorials. Expand the 15 factorials into 9 factorials so that we can cancel out. And multiply the 15 times 14 times 13 times 12 times 11 times 10 and we can get 3,603,600. And factor the 6 factorials and we can get 720. And we can now divide and we can get 5,005. Example number 2. In how many ways can a committee of 3 students be chosen from 5 girls and 6 boys? A. If there must be 3 girls and 5 boys. So we need to solve on how many ways of choosing 3 students from 3 girls. And we have the combination of 3 is taken 3 and it is equal to 1. And for the 5 boys, it is the combination of 5 is taken to 3 and it will be equals to 10. Letter B. If there is no restriction on the gender, we need to simply add the 5 girls and 6 boys and it will be 11. So we have the combination of of 11 is taken 3 and it is equals to 165.